busy session, so we want to get started. I'm going to start. This is a session in which we're going to think about and strategize and help each other figure out what we're going to do with image data management during data generation and sharing after generating the images and when we're ready to share them. So we're going to start with a talk by Nathalie Gaudreault, who is actually a native of Quebec, holds a PhD from the University of British Columbia, and after a postdoctoral career in the Bay Area in California, moved to the Allen Institute of Cell Science, where she has had a stellar career in building microscopy pipelines. And now she is the senior advisor for microscopy, dissemination, and alliances. Beyond the title, Nathalie has been absolutely instrumental in building GBINA as a member from the very start of the Quality Control Data Management Working Group, and QUARE-PLIMI, where she has led the working group on standardizing the quality control for light sources. She will tell us about an amazing initiative which she also has started and initiated from the Allen Institute to actually make sure that in North America we have a way of sharing bioimage data. So she will tell us about prototyping the Internet of Bioimage Data, IBID, which I'm sure will become a name that we will all know for a long time.
Okay. First, I want to thank all the organizers for this wonderful meeting and for giving me the chance to speak today. My name is Nathalie Gaudreault. I can pronounce it properly here. Sorry. It's just my little joke. So I'm here. I'm here today representing the Allen Institute for Cell Science, where I've been leading the image data sharing initiatives with Graham Johnson, who's sitting here in the front. And this initiative, all these efforts have been started by Rick Horowitz. The slides are not moving, by the way. We've practiced too much.
Okay.
Oops. Okay. That will be okay. Okay, so this initiative was started by Rick Horowitz, and throughout the years, actually many of you here have contributed to these efforts. So I'm here today to talk to you about where we stand now with these initiatives and to tell you a little bit more about what we think for the future of this. So let me start with some context and this slide. So a lot of efforts have been put forward to bring data sharing in a fair way all over Europe and Asia. And we've been listening on these conversations for a long time now. And what's becoming clear is North America is largely absent in those discussions. So we want to change that. And so the Allen Institute decided to lead these efforts and started the bioimage data sharing initiatives. And through this initiative, we've set up a bunch of summit and workshop that gathered together a lot of wide perspective on this topic. And this led us to ask this question. So how do we share bioimage at scale? So that we really focused on that. This led us to actually launching this IBID prototype that I will talk to you a bit more about. And knowing that we want to build this prototype, though, I want you to keep in mind that we cannot do this in silo. We want to do this with the community and with a lot of partners from around the world. And why does this matter, this data sharing? Why should we care about making sure that our data can be shared, or image data can be shared with? Because now we're during the post-genomic era, and images are central to all of our data sets. And what's happening at the moment is that we do have a lot of data sharing, image data sharing. It already exists all over the world. There's lots of repositories that exist already, but most of those are siloed. They're hard to find. They're not always interoperable. They can be found on your hard drive in your drawer. And even in-house at the Allen Institute for Cell Science, a lot of our data is located in different locations. They're not all connected yet. This was triggered, this flood of image data being made available was really triggered by the reproducibility crisis. And this was a very good step forward. So we've put a lot of image data available. However, the metadata that's very critical to it was very minimal and often designed purely to reproduce the study presented in the manuscript and was not sufficient for reuse. And what if we want to reuse image that we're sharing, if we want it to be reused, it needs to have richer and more flexible metadata. And it also needs to have the ability to combine data set into new subset of image data. This leads us to another question. What else could be missing for this to work? How could we make sure that all these siloed data set can be found, searched, and reused more easily? So we've been thinking about this question for a long time at the Allen Institute. We want to have all of our data fair and findable and all of this good stuff. And we've started building tools in-house to make this possible. And this now leads us to imagine something different for the rest of the world as well. What if we link all of these silo data and they're now connected and not so isolated? So I want you to imagine extracting this lightweight text-based image data, metadata, sorry, from or heavyweight image data and combine it into a centralized space where we can have access to it, and that would be used to connect all of these siloed image data. So this is a concept that we refer to as the Centralized Metadata Catalog, or CMC. This leads us to this vision we've been having of the Internet of Bioimage Data, or what we call IBID. So I want you to imagine this IBID vision as a nice ecosystem where everything is interlinked easily and all the image data can be found easily and reused easily. So this concept of a CMC brings us to something we've been talking about for a long time as well. This siloed data becomes quasi-federated, and why we call it quasi, it's really because the heavy pixel data remains in their repository with no need for expensive download and duplication, because we can use this CMC to interface and enable searching, exploring, organizing, aggregating, curating, and sharing all of our image data. So this is really this first steps towards IBID, but we should not forget this very critical, important thing here, the metadata. So it really starts there. You cannot achieve this without collecting at the source, while the images are collected, the metadata and making it available with your image data. Now, if we get this right, the benefits are huge. You really need to consider this. So imagine that you're going on the web and you can find this one single movie of an OME czar image, or a beautifully curated image data set that you can use to train your AI engine. All of this could be possible with an IBID. Now, this led us to the roadmap of an Internet of Bioimage Data, and with the image data initiatives, we've identified through a series of interviews with a bunch of you, all experts in the field, to identify specific requirements that are needed to build this together. And for data generation, for example, we believe we need metadata standards, automated capture, file format specification, provenance specification, and quality control. And for data storage and availability, we need criteria for inclusion, plan for scaling and persistent storage, efficient upload and download, security protocols, and finally for access, we'll need search protocols, GUI for metadata filters, web-based visualization and analysis tools, and of course, not to forget training resources. So you've heard all of this in many places, now they're just all gathered in one place with this vision. The image data initiatives also recommended some strategy to implement this roadmap of IBID. And so some of the first requirement will be to develop a community-driven consensus on metadata. Can't escape it. We need to ensure that we have open access, interconnection, interoperability to enable scaling, sustainable data hosting, indexing, and search capability. And we need to create incentive for researchers to see value in sharing rich metadata image data sets. So that's very important. The image data initiatives also recommended to start with exemplar repository with standards and tools that already exist that others could use as a model. And this led us to the prototype, and it also told us to start by establishing a federation of image data repository with a coordinating consortium, something that we don't have yet here in North America. So to start with an exemplar repository with existing tools, the Allen Institute for Cell Science proposed to build a prototype with existing tool that we've built in-house and to try to build this best version of a quasi-federated bioimage repository. And with this prototype, to answer this question, will researchers reuse bioimaging data if it's easy to find, aggregate, and access? We want to do this to demonstrate the value of IBID by gaining insight from building this prototype before we start scaling up, because this is expensive to store all this data on the web and not use it or not see anyone else reusing it. And now we want to use also this prototype as a foundation to build a North American community to drive the internet for bioimage data. So the Allen Institute has proposed to build this proof of concept of a CMC, or this prototype of IBID, using existing tooling, and we propose to use our in-house tool, Biofile Finder, that you've probably already heard because we've been talking about it all week. And now I will very, very briefly just tell you a little bit about this tool. We like to call it our BFF, and we hope that it becomes your own BFF one day too. So this started as a simple centralized file management system in-house for us that was really requested by all the scientists doing the work. And we saw great value in sharing this tool right from the get-go, and it became very quickly a web-based platform that you can already have access to if you go on our website. Now, this is part of a framework, a small little ecosystem, so it can be plugged to other tools. We have BioIO that is used to standardize file format, and then it goes to BFF, who manages all your files. And if you're using web-based visualization tools such as Volley, Agave, or NeuroGlancer, they're already plugged into this BFF, and you can explore any files that you find through it. Okay. BFF is actually a very simple tool. It works on a very simple, flexible spreadsheet. We call it a bff.csv. That's all you really need to load into the browser. The file needs to be organized as a tidy format, so all the rows represent image metadata values, and the columns represent metadata keys, so they're your headers. As long as you have that, you can navigate and find all sorts of things. And if you use it, you can actually access a very large amount of files all in one go and sort them in many different ways and search and aggregates all sorts of things. If you go on our website, for example, you'll be able to visualize multiple data sets that we've put together, over 4 million image files in one go through BFF. Oops, I'll go back, press too quickly. Okay, just one last thing about BFF. It can also change the game in terms of publication. So in some of our publication, we've already started using it. So what you can do is, instead of having just the static images in your figure, you can now add a link to the actual data set that was used to create these figures, and it sends you straight away to BFF, and you can start exploring. And even just a static image representing something can now be linked to a viewer, a web viewer, and so people can not just trust what you're showing them, but go to the viewer directly with the same image data, the raw file, and start exploring. So it adds trust to all of this. So if you have any questions, if you want to know more about BFF, please come see us. We will be at the posters. Antoine's poster is still up. We'll have also computers there so we can show live demos. You can find Graham, Antoine, or I anytime. We'll be happy to help you with that. Now let me just finish with telling you how we want to use BFF to build this prototype of the Internet of Bioimage Data. So we've set up collaborations with other institutes here in North America, such as the Chan Zuckerberg Initiatives, the Broad Institute, the Howard Hughes Medical Institute. So all of these institutes are already well known to provide large data set of high value, well curated, and so forth. So we're going with that to start. It's just the beginning, but we're pulling together all of our metadata, putting it in a centralized metadata catalog, and using BFF to interact with it. And what we're hoping to do is to start answering questions, you know, is this useful? So why we want to do this, once again, it's because together we really believe that publishing data has only values and is only useful if others are using it. There's no point putting it on the web if no one goes and see it. We really, really hope to be able to answer this question. Will researchers around the world engage with shared image data if it's made easier to discover and analyze? And one way we hope to start tackling this kind of questions is to use public contests. So using this prototype, we can announce some contest and start testing things. What can the community do with this? Can they help us find solutions to harmonize metadata? Can they start showing us how they can combine and analyze data sets in new ways? So that's the kind of stuff we're hoping to do. Now, we've already started building this, obviously, and we've hit already some challenges, most of it related to metadata. So even amongst us, these type of institutes who have all the resources in the world, we still have sparse metadata. We also share different type of metadata. That's important. We always say metadata. It's a big word. It means many things for many different people. And if you think of RAMBI, there's many different type of metadata. So some of us have focused on sharing their metrics that they've done through analysis of their big, large data set. Others have really shared metadata related to the samples, the studies, you know, and other things like that. Often our metadata is also very case-specific still. It's not necessarily related to one manuscript, but it's still case-specific, so we need to deal with this. So we've started thinking about potential solution, and we definitely need to have a little bit of a guidelines during our data collection, making sure that we know what type of metadata we want to collect and share. We believe still that using public contests may help us. You know, if we pull the community, they may help us find some solution to these challenges. And the last little thing I'm going to throw here is we have a new project that we just wrote. We haven't started it yet, but it's proposing to actually automate metadata extraction from a folder structures that you would have on your hard drive into a BFF compatible CSV. So that might also help the field. Okay, how am I doing with this? Almost finished here. So looking ahead, you know, the priorities are very clear for us. We know we need to continue building this roadmap towards IBID. We want to capture early lessons from the prototype. And we want to work towards a North American cross-institutional consortium committed to making image data more accessible, reusable, and impactful. It's that simple. I want to thank the entire team at Allen Institute who contributed to a lot of this work, and many other contributors and collaborators who have contributed to this vision. And not all the names are on this. Believe me, I wouldn't have enough room for it. That's it. I want to thank everyone for listening, and I'm very excited to continue this conversation.